Hello everyone, and in today's lesson we are going to learn about shapes in space. Basically, we're going to learn about vertex, edges, polyhedrons, face, base area, base, lateral edges, lateral face, surface area, volume, prism, right prism, oblique prism, dihedral angle, platonic solids, parallel planes, diagonal, isometric, dot paper, perspective drawing, orthographic projection, distance formula, octant, altitude, SKEW lines, and with then some applications to real life. So let's start with the vertex. Vertex or vertices, it's any point where two or more straight lines meet. It's a corner. And for two-dimensional shapes, we can also relate the number of vertices to its name. For example, let's have a pentagon. 1, 2, 3, 4, 5 vertices. 5 means penta, and since it is a polygon, penta plus polygon equals pentagon. And this goes on for many other polygons as the pentagon, hexagon, heptagon or septagon, octagon, nonagon, decagon, and even hendecagon, and so on. Edges. Vertices and edges are more related than you think. The number of sides or edges of a two-dimensional polygon is the number of edges that it has. So it also is related to the name of the polygon, as I said before. An edge is a line segment that joins two or more vertices. Or it can also be the boundary of a shape as a circumference of a circle. Polyhedron. You may be asking, what does that mean? From Greek, polyhedron means many faces, poly meaning many, and hedron meaning face. A polyhedron is a solid with flat faces that are polygons. This means straight sides. Some examples of polyhedrons may be the cube, the triangular prism, and the dodecahedron, as you see on the slide. Faces. A face is any of the individual surfaces of a solid, formed by the edge that meet at a vertex. Base. For two-dimensional shapes, the base of the figure is the bottom line of the shape. In this case, for the triangle, is the line represented in red. For three-dimensional solids, the base is the face which the solid stands on. In this case, represented by the red part on the rectangular prism. Base area. The base area for rectangles and squares, it's base times height. So area equals BH, base times area. And each special shape has a special formula to derive the area of it. For example, the triangle. The triangle is base times height divided by 2. Or area of the base equals BH divided by 2, or 1/2 BH. But why divided by 2? So, first, to start, divide the rectangle in 2 parts. Now, double the triangle and it forms a rectangle. As you learned before, you can calculate the area of it by base times height. And you divide it by 2. And you get half of the rectangle. If you turn it around, you get this figure. Doesn't that look familiar? Yes, it's the same triangle that you had before. Isn't it amazing? Yes. For circle, it's a little bit different. It's the area, it's pi or square. R is the radius, and pi is that irrational infinite number 3.14, and so on. Lateral edges. The lateral edges are the edges that form the lateral face, and also the ones that connect the top of the base and to the bottom base. As you see in red, and for a pyramid, it connects the base to the apex, forming also the lateral face. The lateral face. The lateral face is the surface of the solid which is not the base. Most of the times, the side of it is formed by the lateral edges, which are connected to the vertex, connected to the base, or to the apex, or to another base, in the case of the prisms. Cross-section. This cross-section is a shape that you get by cutting straight across an object. For example, for the triangular prism, the cross-section is a triangle. Prisms. A prism is a solid object with two congruent bases. It's made by flat surfaces and it has the same cross-section all along its length. Here are some examples of prisms. Cube. Yes, a cube is a prism. It has flat faces, two congruent bases, and the same cross-section all along its length, which is a square. A rectangular prism, a triangular prism, and a pentagonal prism. Surface area. The surface area is when you open up a 3D solid to a 2D image. So you can measure the surface that it covers. For example, a square. It has 6 faces, and pretend that one side of it, it's 5. You do 5 times 5, and you get the area of one of the faces. Since there are 6 faces, you multiply it by 6, and you get 150 units squared. And on the easiest way, you can simply just do 6 times the side length squared. And you get the same thing. For the pyramid, it's base of the area of the base, plus 1/2 times the perimeter times the length, that is the one that goes from the apex to the side base, not to the middle of the base, because from the middle of the base to the apex is the altitude, which you're going to look at it later. For all the prisms, the surface area is simply 2 times the area of the base, since it has 2 bases, plus the perimeter times the height. So you do the around of the figure, which is the perimeter, and do how high it is. For a cylinder, it's not so much difference because the only thing that changes is that the perimeter of a circle is its circumference. So it's like it will be 2 times the area of the base plus the circumference times the height, which is this formula here down. It's 2 times pi r squared, which is the area of the base, plus 2 pi r, the circumference times the height. Volume. The volume is measured in cubic units, represented by the number 3 on the top of a number. The volume of the figure represents how much stuff you can fit inside of it. In other words, we can say how many cubes required to fill in completely, like blocks in a box. The volume of a cube is the area of the base times the height. So you can know how much height will be times the base, so you can know how much stuff you can put inside of it. For example, in real life, you can do, for example, you have a library and you're moving that library to another place. And you have books that have the same size. And you have the same size as box for moving. And so you do the area of the box, the volume of the box, and you divide by the volume of each book, and you can know how much boxes will be required to carry the number of books that you have. Right prism. The right prism is a prism that has two bases, one directly above another, and that has its lateral faces as rectangles. Oblique prism is a prism that its bases are not aligned one directly above another. And note that the lateral face of an oblique prism are parallelograms. If you don't know what a parallelogram or a rectangle is, please comment on the comment box and I will post a video just about it. Dihedral angle. The dihedral angle is an angle that is made between two planes. So pretend that you have plane A and plane B, one above another, and it will form an angle. And that will be the dihedral angle. Platonic solids. A platonic solid is a 3D shape where each face is the same regular polygon, the same number of polygons meet at each vertex, this means that each corner, and it means that all the faces are flat. Parallel planes. When two planes are perpendicular to the same line, they are parallel planes. This means that they can go on forever and they will never touch each other. Isometric dot paper. An isometric dot paper is a paper with carriers of spaced dots with the same distance between them. So we can draw perfect shapes and 3D images on it with almost no errors. Perspective drawing. The perspective drawing is a technique used to make the drawing which you can see as a real space with deep and depth and dimensions, or how far it is or how close it is depending on the point of view of the viewer. As you can see on this image, these painters, they do a deep perspective image on the floor of the street. So when you take a picture of it, depending on the point that you take it, it's gonna look like you are flying on the land, but you are actually standing on the floor. It just looks like the drawing has perspective. Orthographic projection. An orthographic projection means to represent 3D dimensional objects in 2 dimensions. So kind of a plane view of it. For example, the floor plan of a house, it's not actually the 3D house. So you can see just the floor plan is a view from the top of the house. And you can also have a house where you see it from the front or from the back or from the sides, and you're gonna get a flat image. The distance formula. The distance formula is made to calculate the distance between 2 points. So pretend that you have 2 points in a coordinate plane. So you name it AB. And you make a line between them. Now you're gonna know that if you make 2 lines from on the x-axis and y-axis, you're gonna get a right angle. So from the formula that you know from the Pythagorean theorem, if you watched our last videos, you're gonna notice that it's c squared equals a squared plus b squared. So this way you can measure the point from point B to point A. Now you know that A, it's x2 minus x1 because you have the coordinates. And you can notice by the y-axis and the x-axis. For B, it's y2 minus y1, and you get the number of the coordinate of that point. Now you do c squared equals, you apply the numbers or the values that you got for A and B on the Pythagorean theorem form. So you do c squared equals x2 minus x1 squared plus y2 minus y1 squared. But your c squared is a square value. So you can simply do the square root of everything and you get out of that square number. So you do c squared equals the square root of x2 minus x1 squared plus x2 minus x1 squared, and that's it. An octant. An octant is an instrument, or in plane geometry, it's a measure of if you divide a full circle into 2 congruent parts. This means on the middle, on the half, and on the diagonals of it, kind of. And you get the 45-degree perfect parts, which we name it octant. An octant for 2-dimensional shapes is from the middle of the base to the top or the apex, and for 3-dimensional shapes is not the slant height, is the altitude is from the middle of the base to the apex, making a straight line. Skew lines are 2 or more lines in the 3-dimensional shapes or greater than that even though they're not parallel, they will never intersect each other because it's a 3D plane, 3D space. So hey guys, and thank you for your attention. I hope you enjoyed, and if you had any doubts, please comment it below because I'll try to help you the best I can for that you understand everything about geometry. Bye!